we calculate the surface areas and volumes of solid shapes in the unit known as the mensuration. So, first thing, or the two objects which considered firstly are cubes and cuboids. So, today's chapter is surface areas and volumes of cubes and cuboids. So, we must understand what is a cuboid and what is a cube. In fact, in a room where you remain to sit, where you study, or your study hall, your dining hall, most of the objects, most of the rooms we find in the shape which are having length, breadth and height. So, if length, breadth and height are perpendicular to each other, then shape so formed is known as the cuboid. What is the cube? If all dimensions, that is length, breadth and height of any cuboid are same, such cuboid is known as a cube. Now the question is that how we find the surface areas and volumes of a cube and cuboid. Before it, I want to tell you, a cuboid or cube is made up of 6 rectangular surfaces. Like in a room where in your class you study, on the floor you remain to sit is the first surface, and above to it there is a roof, second surface, and there are 4 walls in a room. These are the 4 other surfaces. So, a cuboid is comprises of 6 rectangular surfaces, number 1. So, number of surfaces in a cube or in a cuboid is always 6. A cube or cuboid having 12 edges. What are 12 edges? There are 4 lengths, 4 breadths and 4 heights. Out of these 4 are identical, all 4 heights are of equal length, all 4 lengths are of equal size, all 4 breadths are of same size. So, if someone asks you how many surfaces are there in a cube or cuboid, 6, how many edges are there in a cube or cuboid, 12, how many vertices are there in a cuboid? In a cuboid or in a cube there are 8 vertices. Vertex is that point where your 3 edges meets, that is length, breadth and height. Now I want to tell you the results which are required for solving the problems related to cube and cuboid. In fact, we need 3 things to calculate the surface area, the length of diagonal, the volume of cube and cuboid. Length, breadth and height are 3 important components. Surface area of a cuboid, that is area of all 6 walls, all 6 faces, 2 into length into breadth plus breadth into height plus height into length. But in case of cube, surface area becomes 6 into side, that is all 6 faces of a cube are identical. So, it is 6 into side. Now, if I talk about area of 4 walls, in case of cuboid, the formula is 2 into height into length plus breadth. But you know 2 into length plus breadth is named in the mensuration perimeter. So, we can say area of 4 walls for a cuboid is perimeter into height also. It is 2 into height into length plus breadth or perimeter into height. In case of cube, the formula is 4 into side. Volume, if you talk about for a cuboid, it is length into breadth into height, or you can say length into breadth known as area. It can also be written as area into height. Volume of cube is given by side whole cube, that is side into side into side, because length, breadth and height of a cube are same. If you talk about length of diagonal, you must know what is the diagonal. Diagonal is that edge, diagonal is that line segment which joins one vertex on one face to the other vertex where none of the face meet from where this diagonal has started. So length of the diagonal in case of cuboid is given by root of L square plus B square plus H square. LBH, again I am telling you, stands for length, breadth and height, and diagonal of the cube is given by side into root 3, direct formula. Number of edges in cube and cuboid is both 12. Number of surfaces is 6 and 6. Number of vertices is 8 and 8. And I want to tell you that number of diagonals is given by 4 in numbers in both the cases. Whether it may be cube or cuboid, number of diagonals is given by 4. There are 4 diagonals in cuboid as well as in cube. We will apply these results to solve the problems based on cube and cuboid for their surface areas and volumes. Now I want to explain you one of the example with the help of results how to calculate the surface area and the total perimeter of cuboid. The question is, a small indoor greenhouse herbarium is made entirely of glass panes, rectangular pieces of glass, including base. Base is also of the glass. The length, breadth and heights are 30 centimeter, 25 centimeter and 25 centimeter. Find the area of the glass required to make this herbarium and length of the tape needed for all 12 edges. That is, first I want to write in the solution. That length of cuboid is given how much? 30 centimeter. Then breadth of cuboid is 25 centimeter and height of cuboid is 25 centimeter. Because all 6 surfaces of the cuboid are made up of the glass, so I want to calculate the total surface area of all 6 faces. Surface area of cuboid. Surface area of cuboid is given by the formula 2 into L into B, B into H plus H into L. So this becomes twice of length into breadth, 30 into 25, breadth into height, 25 into 25, height into length, 25 into 30. So this becomes 2 into 750 plus 625 plus 750. This becomes 2 into 2125. The addition of 750 plus 750, 1500. 1500 plus 625 become 2125. This product is coming out to be, this will be 50, this will be 4250 centimeter square is the total area of the glass required to make this cuboidal herbarium. First answer. Length of the tape for all 12 edges. So length of tape is how much? Because tape will be fixed on all 12 edges, because length of tape is equal to total perimeter, that is 4 lengths plus 4 breadths plus 4 heights, that become 4 into L plus B plus H, coming out to be 4 into length 30, breadth 25, height 25. So this become 4 into 25, 25, 50, 50 plus 30, 80. 80 into 4, this become 320 centimeter long tape is required to put the tape on all 4 edges. Next example, where I am taking the application of the surface area and how to find the cost. Question is, the length, breadth and height of a room are 5 meter, 4 meter and 3 meters. A room is 5 meter long, 4 meter wide and 3 meter high. Find the cost of whitewashing its 4 walls and ceiling at the rate of rupees 7.50, that is at the rate of rupees 7.50 per meter square. So first of all, we should know that what area is to be painted, as clearly given in the question, that all 4 walls including the ceiling, these 5 surfaces are to be painted, that is floor is need not to be painted. So what we will do, first we will calculate the area of these 5 surfaces, that is what, area of 4 walls plus area of ceiling. To calculate the required area, that is area of 4 walls plus area of ceiling, I will write here length is given as 5 meter, breadth is 4 meter and height is 3 meter. Length is 5 meter, breadth is 4 meter and height is 3 meter. Required area is required area is equals to area of 4 walls plus area of ceiling You know that area of 4 walls is given by 2 into height into length plus breadth, and area of ceiling is always same the area of floor. So area of floor is length into breadth. If I substitute the values of length, breadth and height, 2 into 5 into length plus breadth, 2 into height is 3, into length is 5, breadth is 4, plus length into breadth 5 into 4, result is coming 6 into 9 plus 20, that is 54 plus 20, 54 meter square is the area of 4 walls, 20 meter square is the area of ceiling. This answer will come out 74 meter square. Cost of painting 1 meter square is rupees 7.50. So cost of painting the required area, cost of painting of which area? Required area is how much? 74. So this become rupees 7.50 into 74, rupees 7.50 into 74. This product will come rupees 555. So answer is, that is the cost of painting of the 4 walls with the ceiling at the rate rupees 7.50 is 555. Find the surface area of a cube if its diagonal is 4 root 3 meter. In fact, the formula for calculating the length of the diagonal of a cube is side into root 3. Let side of cube is x meters. So, length of its diagonal, is side into root 3. This implies x root 3 is equals to 4 root 3 as per question. We have assumed the length of the side of the cube is x meter. Therefore, the length of diagonal is side root 3, or you can say x root 3. But the value of the length of the diagonal in meters is given as 4 root 3. This becomes x root 3 is equal to 4 root 3. This implies x is equals to 4 meters. That is, you can say side of the cube. Side of cube become 4 meter. So, its surface area is 6 into side, that becomes 6 into 4 into 4, that becomes 6 into 16, that becomes 96 meter square will be the surface area of that cube whose length of diagonal is 4 root 3 meters. Now I want to take one more problem based upon the surface area concept. 3 equal cubes. We have 3 cubes which are equal in size. 3 equal cubes of the same size are placed adjacently in a row. Find ratio of total surface area of new cuboid. If I will place 3 cuboids in a row, then what will form? A cuboid will form. Then they are asking find the ratio of total surface area of new cuboid to the sum of the surface areas of 3 cubes. Let each side of each cube is x units. If I have 3 cubes, each having the side x units, and these 3 cubes are placed adjacently, then what is going to happen? The new shape whatsoever will form will be a cuboid. That will be a cuboid, and the size, that is the length of cuboid, length of the cuboid so formed will be 3x, x plus x plus x. Then breadth of cuboid will not change, that will be x, and height of cuboid will also not change, will remain x units. Now the question is how to find the surface area of a cuboid. This will be surface area of cuboid formula, you know, 2 into length into breadth, that is 3x into x, 3x square, breadth into height, x square, height into length, 3x square, 3 plus 3, 6 plus 1, 7, 2 ja 14x square unit is the surface area of the cuboid so formed. We want to find the ratio of this area to the area of 3 cubes. Area, that is surface area of 1 cube is equals to 6 into x square. Surface area of 3 cubes is equal to 6x square into 3, that is 18x square. Now we want to calculate these two ratios. So I will write here required ratio of surface areas of the cuboid so formed to the surface area of 3 cubes is equals to 14x square is to 18x square its simplified form will be 7:9. Now one of the very important question related to the surface area of the cuboid. It is find the surface area of a cuboid if sum of length, breadth and height, that is L plus B plus H for a cuboid is 12 meter, and the length of diagonal means root of L square plus B square plus H square is given 5 root 2 meter. This is equation 1, this is 2. What is required? We want to calculate the surface area of the cuboid if length plus breadth of plus height for the particular cuboid is 12 meters and the length of diagonal is 5 root 2 meter as given. Now if I ask you to square equation number 1, on squaring equation number 1, this will be L plus B plus H whole square is equals to 12 whole square. This become L square plus B square plus H square plus 2 into L into B plus B into H plus H into L. This is L into B plus B into H plus H into L is equals to square of 12 is 144. Here I have applied the formula of A plus B plus C whole square, A square plus B square plus C square plus 2 into A into B plus B into C plus C into A is equal to 144. If I ask you to square of equation 2, on squaring equation number 2, this will be L square plus B square plus H square left hand side. Square of 5 root 2 is what? 50. 5 5 ja 25, 2 ja 50. This is relation number 3 and this is 4. In equation 3, in place of L square plus B square plus H square, we can write 50. If this value of L square plus B square plus H square from equation 4 is put in 3, then it will be 50 plus, you know, 2 into L into B plus B into H plus H into L is what? Surface area of cuboid. Surface area of cuboid is 144. Hence on solving this we will get that surface area of cuboid is 144 minus 50, that is 94 meter square. So bit of the algebraic identity was required, a little bit replacement, and directly we can calculate that surface area of this cuboid is 94 meter square. One problem based upon the volume. A river 3 meter deep and 40 meter wide is flowing at the rate of 2 km per hour. How much water will fall into sea in 1 minute? Here the speed of the water is given in kilometer per hour, where the depth and width of the river is given in meter, and the water is required of the time 1 minute. So we need to very conscious about their units. So first of all I want to tell you that length of water flowed in 60 minutes. In place of 1 hour I can write 60 minutes is how much? 2 kilometers. I have to write this 2 kilometer as 2000 meters because 1 kilometer is 1000 meter. So 2 kilometers are equal to 2000 meter. That is, water from here to here in the river is moving how much? In 1 hour it is moving 2000 meters. In how much time? 1 hour. So length of water flowed through this river in 1 minute. Length of water flowed in 1 minute. In meters, this is 2000 upon 60 because 1 hour 2000 meters. So you can say in 1 minute it is 2000 upon 60, which will come out equal to 100 upon 3. On simplification, 200 upon 6, 100 upon 3 meter. Breadth of river is given equal to 40 meter, and depth, which can be considered as the height, if I consider this is a cuboid, is 3 meter. So volume of cuboid is given by length into breadth into height, which is coming out to be length 100 upon 3, breadth 40, and the height is 3. So this result, when 3 and 3 get cancelled, comes out to be 4000 meter cube. Hence the conclusion is, if river is flowing at the rate of 2 km per hour, then width 40 and depth 3 meter, then the water which will be given to sea by the river in 1 minute will be 4000 meter cube, as all details and regions are given you. One more problem. A solid cube of side 12 centimeter. We have a big solid cube whose each side is how much? 12 centimeter. A solid cube of side 12 centimeter is cut into 8 cubes. This solid cube is divided into 8 small cubes, all of same size. Find the number of cubes. I am supposing, let side of a small cube is x centimeter. Side of the small cube is x centimeter. Number of cubes cut. How many cubes have been made? That is 8 small cubes, that is 8. So there will be one thing same, volume of big cube will be equal to volume of 8 small cubes. Volume of one big cube is equals to volume of 8 small cubes. One big cube is 12 into 12 into 12 is equals to 8 into small is x cube. So x cube is equals to 12 into 12 into 12 upon what? 8. So answer of x cube is 216. Hence x is equals to 6 centimeter. So we can say that here find the, in place of finding the number of cubes it is given, we have to find the side. Find the side of cube. Also find the ratio between their surface areas. How to find that ratio of surface area? Surface area of the big cube is surface area of big cube. It will be 6 into 12 into 12, and surface area of a small cube will be 6 into side square, side is also 6. So ratio will be, ratio of surface areas will be 6 into 12 into 12 upon 6 into 6 into 6, that is 4 upon 1, or we can say it is 4:1. Hence a solid cube of side 12 centimeter, when it is cut in the 8 small cubes of the same size, find the side of cube, that is 6, and find the ratio between their surface areas, that ratios are 4:1. The areas of three surfaces of a cuboid are x, y and z square units. then prove that the volume is equals to root of x into y into z. I want to tell you, if there is a cuboid and there are 6 faces, out of these 6 faces 2 are identical. 2 are identical. Area of the first face is x, area of the second face y, and third face z. I am taking here, let the length of what? Cuboid is L. Breadth is, I can say in place of L, A, breadth is B, and height is C. So answer of x is length into breadth, that become A into B. Y, second face, area of the second surface is breadth into height, that is B into C. And Z, third surface, it is H into L, is C into A. Now x into y into z. X means A into B, x means A into B, x means A into B, y means B into C, and z means C into A. So x into y into z become ABC whole square. A is length, B is breadth, C is height. So x, y, z become volume whole square, because length into breadth into height is volume. You know that volume is equal to LBH. So volume become ABC. We know that volume is equal to LBH. So volume become ABC. Here in place of ABC I have replaced volume. As volume square is XYZ, so you can say volume is equal to root of XYZ. This is a required result what we need to solve. One combined question where surface area and volume both will be used. If V is the volume and S is the surface area of a cuboid of sides A, B, C, that is length A, breadth B, and height C units, then prove that 1 upon V is equals to 2 upon S into 1 upon A plus 1 upon B plus 1 upon C. This is volume is equals to length into breadth into height. So volume become A into B into C. Now the left hand side will be 1 upon V, which will be 1 upon A into B into C. We can call it relation number 1. Now if I talk about right hand side, here you know that right hand side is 2 upon S into 1 upon A plus 1 upon B plus 1 upon C. Here S stands for surface area, and you are very much sure about the surface area of a cuboid is given by 2 into what? Length into breadth plus breadth into height plus height into length. That is A into B, length into breadth plus breadth into height, B into C plus C into A, that is height into length. Now LCM of this part is A, B, C, and here we will get A when cancelled BC plus CA plus AB. You can observe these two can be cancelled, 2 can be cancelled, we can get 1 upon ABC. So left hand side is 1 upon ABC. The value of the right hand side is also showing 1 upon ABC. So what conclusion we can draw? For a cuboid having volume V, 1 upon V's answer will be equal to 2 upon S times of 1 upon length plus 1 upon breadth plus 1 upon height. The proof is shown here, that is left hand side is what? Length into breadth into height, volume ABC, and it is 1 upon V means 1 upon ABC. Right hand side is required as 2 by S multiplied by 1 upon A plus 1 upon B plus 1 upon C. Value of surface area in case of the cuboid is given by 2 into AB plus BC plus CA, and after taking LCM we are getting the numerator of this component as same. So simplification is this giving 1 upon ABC. So answer of 1 upon V is 1 upon ABC, and answer of right hand side is also 1 upon ABC. So conclusion comes that in case of cuboid this relation holds true. Now I would like to discuss with you the surface areas and the volume of a right circular cylinder. Before it, I will tell you the results which we will use to solve the problems. I want to tell you how a cylinder can form. If you have any rectangular piece of paper, as I have in my hand, suppose the length is L and breadth is B, or you can say length is given by A, breadth by B. There are 4 possibilities, 4 ways to make the cylinder with the help of this piece of paper. The first attempt, you can roll it along its breadth. This is the breadth. If you roll it along its breadth, then a cylinder will form. So any rectangular sheet of paper, when rolled along its breadth, then the breadth become its circumference and the length become the height of cylinder. So first way to form the cylinder with the rectangular sheet, which you can also make, is this, that you have rolled the rectangular sheet toward its what? Breadth. Then in this case, breadth become the circumference and length become the height. But if you want to roll it along its length, then in this situation, if you will roll it along its length, then again the shape will be the cylinder, as you can see, and the length becomes circumference and breadth become the height of cylinder. This length become the circumference and the height is equal to the breadth if you will roll it along length. So remember, when you roll a rectangular sheet of paper along its length, then length will be the circumference and breadth will be the height. And if you will roll it along its breadth, then the breadth will convert to circumference of cylinder and length will be the height. Number 1. Number 2, as I shown you, you can roll a rectangular piece of paper in 2 ways, one along length, one along breadth. So 2 types of cylinder are possible. But if you fix its length and you rotate this piece of rectangular sheet of paper, then you can observe that what amount of the space is occupied by rolling this rectangular sheet of paper. In the space is the cylinder, where this height is equal to the length of the rectangular piece and this breadth become the radius of the cylinder. This is the third situation. Fourth, if you roll, if you revolve, if you make rotation of the rectangular sheet of paper by keeping its breadth fixed, then this breadth will be its height and length will be the radius. So first question, that how a right circular cylinder forms, must be clear. Now I want to tell you what are the surface areas results, total surface area and volume of a right circular cylinder. Now I want to discuss with you the results required while solving the problems of the right circular cylinder. That is, the first result is volume of cylinder is given by pi r square h, where r is the radius of base and h is the height of cylinder. As you know, pi r square is the area of base of the cylinder, because base of cylinder and top of cylinder is a circle. Both are identical circular ends. That is, pi r square can be written as area of base and h is the height. So there are two results, one pi r square h and its another form is area of base into height. Number 1, curved surface area or lateral surface area of a cylinder. What is curved? If you have a cylinder like this, then only and only this rolled part is known as curved or the lateral. That is, if you have a cylinder like this, then only this part which is round, this is known as the curved surface area. Curved surface area or lateral surface area of cylinder is 2 pi r h, where 2 pi r you know very well is known as the circumference. So we can call 2 pi r is the circumference into h means height. Then if you talk about the total surface area, if you can complete a lid and a base, it means you have closed this cylinder, then what is the total surface area? Area of this curved, that is 2 pi r square, 2 pi r h, plus one of the top pi r square, same another top pi r square. So it become 2 pi r h plus pi r square plus pi r square, which is coming 2 pi r h plus 2 pi r square, 2 pi r into r plus h. This is the concluding formula for getting the total surface area of a cylinder. Now volume of a hollow cylinder. Hollow cylinder is that cylinder which has thickness. Thickness is always calculated by subtracting internal radius from the external radius. That is, volume of hollow cylinder of, if it is given internal radius is small r and external radius is capital R, with the height h, pi capital R square minus small r square into height. If you talk about how much material is used, this will be the volume, and when this volume will multiply it by the given density, then weight of that material used to make the cylinder will come out. Total surface area of a hollow cylinder. Internal area, that is 2 pi r h. External area is what? 2 pi small r h, because height will remain same. And area of two rings. There will be two rings of some thickness. Area of one ring is pi r square minus r square. So area of two rings is 2 pi r square minus r square. So total surface area of a hollow cylinder is given by external surface area plus internal area plus area of two rings. Area of one ring is given by pi capital R square minus small r square. We will use these results to solve the problems related to the right circular cylinder for obtaining the volume and surface area. If I show you in the figure, there is a cylinder. The cylinder is the shape. Here the radius of this cylinder is given to be 14 centimeter and the height is 21 centimeter. What we need to calculate? We need to calculate area of base. The first thing which we want to calculate, area of base. So first, area of base of cylinder. Wherever I am writing cylinder, you must understand it is a circular, that is right circular cylinder. You know very well that the base of the right circular cylinder and top of the right circular cylinder are two identical circles. So finding area of base of the right circular cylinder means finding area of circle, that is pi r square. Here pi 22/7, r is 14 into 14, If I simplify, I will get this is 616 centimeter square, first area. Second, if I talk about curved surface area, that is the curved surface area of cylinder. It is given by 2 pi r h, that is 2 into pi means 22 by 7, r means 14 and h means 21. After simplification, this is 1848 centimeter square. This is the area of the curved surface directly by using the formula. Third, the total surface area, TSA of cylinder. TSA of cylinders formula is 2 pi r into r plus h. That value will come 2 into 22 by 7 into r means 14 into 14 plus 21, which gives us after cancellation, that is 2 into 2 4 into 22 88, 88 into what 14 plus this, it becomes 35. This result after multiplication gives us 3080 centimeter square. This is the total surface area. If you talk about the volume of cylinder is given by the formula pi r square h. So this become pi means 22 by 7, r square means radius into radius, that is 14 into 14, into height means 21. The simplification of this gives us 12936 centimeter cube. So this is the question where we have applied the radius and height directly to find area of base, CSA, TSA and volume. You need to be very specific while you are writing the values. You please take care about the units. For area it is unit square and for volume it is a cube unit. Now I am taking an example where we will use the curved surface areas formula. The height of a cylinder is 15 meters. That is small h we use to indicate the height of cylinder 15 meter. The curved surface area CSA shortcut 660 meter square. Find its radius. Radius of the cylinder is required. I am writing, let radius of cylinder is r meters. So according to given condition AGC, according to given condition, CSA's formula we know it is 2 pi r h. CSA is 660 meter square, 2 into pi 22 by 7, radius r and height 15. So with the help of this relation, radius will be 660 into 7 upon 2 into 22 into 15. So you will simplify, you will divide and multiply and get radius is equals to 7 meter. Hence radius of the cylinder is 7 meter. Now the next example, the curved surface area, CSA means curved surface area of a cylinder is 4400 centimeter square and the circumference of its base is 110 centimeter. Find the height of cylinder. As given that CSA, curved surface area, CSA of cylinder is 4400 centimeter square and what more, circumference of base is given 110 centimeter. What is required in this question? Required is calculate its height. You know that CSA is given by 2 pi RH, or you can say CSA is given by 2 pi r means circumference. You can say formula for curved surface area is circumference into height. Now value of circumference is given 4400 centimeter square. Circumference is given 110 centimeter. Into height is required. So answer of height is 4400 divided by 110 gives us 40 centimeter. Hence for this question the height of cylinder to satisfy must be 40 centimeter. Now I am taking a question where the hollow cylinder will be considered to discuss the problem. A metallic pipe in the shape of hollow cylinder is 77 centimeter long. As you can see, this is a pipe hollow, its length is 77 centimeter. The inner diameter of the cylinder is 4 centimeter. I can say diameter inner is how much? 4 centimeter. So radius, which radius? I can say inner radius. Inner radius. Inner radius we try to replace by small r. Radius is half of the half of diameter, so it become 2 centimeter. Now its inner diameter is given 4, so inner radius become 2. Similarly, diameter outer diameter, external diameter is 4.4 centimeter. It is 4.4 centimeter outer diameter. That's why I can say diameter outer is 4.4. So capital R is half of the diameter, 2.2 centimeter. The length of the pipe will be taken as the height. Height is 77 centimeter. What is the total surface area of cylinder? Total surface area of a hollow cylinder. You can recall the formula. It is outer surface area, that is 2 pi capital RH, plus inner surface area 2 pi small rh, plus area of two rings, that is 2 pi, you can say capital R square minus small r square. To find this area we have all data, we just need to put the values. This is 2 into pi means 22/7, outer radius 2.2 into height 77, 2 pi capital R into h, plus 2 into pi means 22/7, inner radius is 2 units, into height same 77, plus 2 into pi means 22/7, capital R outer radius 2.2 whole square minus inner is the 2 square. When we will simplify this value, I will get 1064.8 centimeter square. This is the area of the outer. Inner, this value will give us 968 centimeter square, and area of both rings 2 pi capital R square minus small r square. This calculation leads us to 5.28 centimeter, 5.28 centimeter square. If I ask you to calculate the total, so this plus this plus this, it is 2000, this 0.08, 0.08 centimeter square is the total surface area of this hollow cylinder having external dia 4.4, internal dia 4 and length, that is height, 77 centimeter. Apply direct formula and get the answer. Now one more question. The volume of a cylinder is 448 pi centimeter cube. There is a right circular cylinder, its volume is 448 pi centimeter cube. Find its radius. If it is 7 centimeter high, that is height of cylinder is 7 centimeter. Also find its CSA. So I can say, and the volume of cylinder. The volume of cylinder, we know that pi r square h. The volume of cylinder is mentioned here 448 pi is equal to pi r square into height is 7. I have not put here the value of pi because I can see pi and pi will cancel. So 448 is equals to r square into 7, or r square is equals to 448 upon 7. After cancellation, this comes to be after division 64. R square is 64, so r is equals to 8 centimeter. Hence, first answer, the radius of the cylinder will be 8 centimeter. Also find its CSA. CSA of cylinder, formula is 2 pi RH, meaning by 2 into 22 by 7 into radius 8 into height 7. This get cancelled. So I can say it is what? 44 into 8. So 8 4 ja 32, then 8 4 ja 32 plus 3 35. So this is 352 centimeter square is the curved surface area of this cylinder. Now I am taking an example where is a hollow cylinder. We will use the concept of the volume of material used. The difference between outside and inside surfaces of a cylindrical pipe 14 centimeter long is 44 centimeter square. Means we have one hollow pipe. I am showing that pipe shape here. It may be of this type as I am showing. What is there? The difference between outside and inside surfaces of a cylindrical pipe 14 centimeter long. This is 14 centimeter in length. The difference of the outer surface area and inner surface area is 44 centimeter square. And pipe is made up of 99 centimeter cubic of metal. Means difference between outer volume and inner volume is 99 centimeter cube. Find outer and inner radii. Let outer radii is capital R and inner radii is small r. Now the question is that difference of the surfaces 2 pi RH minus 2 pi small rh. That is given how much? 44 centimeter square. This is outer curved surface area. This is inner. Their difference is 44. So I can put the value of height, that is 14. I will say 2 into 22 by 7 into 14. 2 into pi into h common. 2 into pi into h common. So inner portion will be capital R minus small r is equals to 44. On simplification, I can say r minus r is 1 by 2, equation number 1. pipe is made up of 99 centimeter cubic metal, means outer volume minus inner volume is 99. Outer volume is pi capital R square H minus inner volume pi small r square H, difference is 99. If pi H is common, it is R square minus R square 99. Pi means 22 by 7, H means 14. R square minus R square can be written as R minus R into R plus R is equals to 99. Why? A square minus B square is A minus B into A plus B. From equation 1, R minus R is half. So I can say 7 2 ja 14. 44 in place of R minus R, half into capital R plus small r is equals to 99. On simplification, this result I will get R plus R is equals to 9 by 2, equation 2. R minus R, that is outer radius minus inner radius is half, outer radius plus inner radius is 9 by 2 by using the given concept, that is difference of surfaces and difference of volumes. If I request you to solve equation 1 and 2, you will say capital R is 2.5 centimeter and small r is 2 centimeter. Once you need to add these two equations and once you need to subtract. When you will add, you will get the outer radius. When you subtract, you will get the inner radius. Now I want to discuss with you a problem where volume of cylinder is to be calculated. When a rectangular sheet of paper 44 centimeter by 22 centimeter means 44 centimeter long and 22 centimeter wide is rolled along the length. When a sheet is rolled along the length, then we can say the circumference is equal to 44, that is 2 pi r is equal to 44. Why circumference 44? Because it is rolled along the length. So you can say here radius is equal to 44 upon 2 into pi, 22 by 7. So radius comes out to be 7. Height is the breadth. Height is 22 centimeter. A rectangular sheet of paper 44 centimeter long, 22 centimeter wide is rolled along the length to form a cylinder. Find its volume. Volume of cylinder is given by pi r square h. That is pi means 22 by 7, r square means 7 by 7 into height. Height is 22. So this is cancelled and the result is 2772 centimeter cube. So this kind of problems can be solved just by taking care that sheet is rolled along which side. If it is rolled along length, length is circumference. If it is rolled along breadth, then breadth will be circumference. If length is circumference, breadth is the height. If breadth is circumference, length is the height. Now I want to explain you one important component of our mensuration, that is the volume and surface areas of a cone. The first thing, how a cone forms and what is the easiest approach so that we can explain you the formation of the cone. The important part is, if I have a right angled triangle as I am showing you here, the name of the three sides of a right angled triangle is given by base, perpendicular, hypotenuse. If by keeping this perpendicular fixed and this is revolved, rotated about its base, then you just can imagine then what amount of the space is occupied by revolving, by rotating this cone in the space the figure so formed. The figure so formed will be a cone. How a cone will form? If a right angled triangle as shown to you is revolved or rotated by keeping its either base or perpendicular fixed, then what so space is covered in the rotation of a right angled triangle, the shape so formed is known as a cone. In this case, I have fixed this perpendicular and I am revolving its base. So in this case, what cone will form? The perpendicular will be the height of cone and the base will be the radius of cone, and the hypotenuse of the right angle triangle will be its slant height. Number 1. In case if you want to rotate by keeping its base fixed, if you are rotating it like this, then again the amount of space used in the rotation of this right angle triangle about its base, what so figure will form will also be the cone. But here this base will be the height and this perpendicular will convert to the radius of cone, but length of hypotenuse will known as the slant height of a cone. Now you can ask me that we can revolve or rotate a right angle triangle about its base or about its perpendicular. If you are rotating like this, then you are rotating it about the perpendicular. Then perpendicular become height and base become the radius. And if you are rotating like this, then this part become height and this become radius. If someone has rotated it about its hypotenuse, then what will happen? You will come to know the concept of double cone. If a right angled triangle is rolled or rotated about its hypotenuse, then what so form or amount of space occupied in revolving a right angle triangle about its hypotenuse is known as a double cone. I have shown here a figure. This, as I am indicating, this is a cone. Here you can observe this part AD. This is the height of cone. The part DC or BD, this is the radius of base. The part AC is known as the slant height. So how it has formed? You just can see that there was a triangle right angled ADC, then AD is kept fixed, that is the right angle triangle ADC or ADB is revolved or rotated about the height, then figure so formed is a cone. Now this is height of cone, this is radius of cone, this is the slant height of cone. So you can see about the cone, radius is BD or DC or indicated by the small r. Height is AD as shown and indicated by small h. Slant height is, you can see, AC or AB. Symbol is small l, and with the help of Pythagoras theorem, it is base square plus perpendicular square, that is root of r square plus h square. If you talk about its volume, the volume of the cone is given by 1 by 3 pi r square h. Curved surface area, you know which part is curved? Where the base is not involved, that is the part which is rolled. So the volume of the cone is 1 by 3 pi r square h. Curved surface area or lateral surface area of the cone is given by pi into r into L, where I have told you L is the slant height calculated by the formula root of r square plus h square. Total surface area of a cone, that is CSA plus area of base. You know the base of a cone is a circle and the radius of circle is known as the radius of the cone. So TSA of cone By adding area of base and curved surface, answer comes pi r into r plus L. Area of the base of the cone, that is area of circle, is given by pi r square. So we have to memorize these results with all logics, and we will apply how to solve the problems related to the cone. I am taking an example where volume, slant height, lateral surface area, total surface area of a cone are required to calculate. Find volume, CSA, curved surface area, TSA, total surface area of a cone of height 24 centimeter and radius 7 centimeter. I can take it like this. If I draw the shape, suppose this is the cone leveled as A, B, C, D. Here radius of the cone is how much? 7 centimeter. And the height of cone is 24 centimeter. This is 7 and this part is 24. 24 centimeter and 7 centimeters are radius and height respectively. But there is one more height in a cone, that is known as the slant height. To calculate the slant height, we can say slant height is given by L is equals to root of R square plus H square, which become root of 7 square plus 24 square is equals to root of 49 plus 576. This becomes 625 and its square root comes to be 25 centimeter. So we can say the slant height of this cone is 25 centimeter. Now we want to calculate its volume. The first thing, volume of the cone is given by 1 by 3 pi r square h. That is 1 by 3 into pi. I am calculating the volume, CSA and TSA in terms of pi, into r square, that is 7 into 7, into h, that is what? 24. That is 1 by 3 pi r square h, 1 by 3 pi into 7 into 24. 3 8 ja, 7 7 ja 49. This become pi into 49 into 8. So after calculation of this, now I can say this product will be equal to, now I can say that the product of pi into 49 into 8 is equals to 8 9 ja. So 8 9 ja 72, it is 2, carry 7, 8 4 ja 32, 32 plus 7 become 39, 392 pi centimeter cubic is the volume of the cone in the given dimensions. Now I will tell you the second thing, that is the CSA, curved surface area. Formula of the curved surface area is pi into r into L. I am giving answer of the CSA in terms of pi into r, radius is 7, into L, that is what? L is 25. So this become 175 pi centimeter square is the curved surface area of this cone. The third thing is the TSA. Total surface area of the cone is given by pi into r. Total surface area of the cone is given by TSA is equals to pi into r plus L, which become pi into r. R means 7 into r plus L. R plus L means 7 plus 25. So this become pi into 7 into 32. So 32 into 7, its product will come 7 2 ja 14, 7 3 ja 21 and 1 carry 22, so 7 2 is 14, 1 7 3 is 21, 22 pi centimeter square is the total surface area of this cone. Now one more question I am taking. Find the volume of the largest cone that can be cut out from a cube of side 14 meter. From a cube whose each edge, length, breadth, height 14 meter, as it is a cube, so all has to be equal. We want to carve out a cube of maximum volume, or you can say maximum size, largest. That is, in this case of the largest, the diameter of the cube, diameter of cube will be equal to diameter of cone. Diameter of cone is equals to side of cube. That is, 2r is equals to 14 meter. This implies r is equals to 7 meter. Now height. The height of cone. Height of cone will also be equal to the side of cube is equals to side of cube. That is, the height h is equals to 14 meter. Find the volume of the cone. If you want to calculate the volume, we need what? Radius and height. Radius becomes 7 because diameter is supposed to be equal to the side, and that is 14 because it is largest. Height is equals to total height of the cube, that is 14 meter. Volume. Volume is equals to 1 by 3 pi r square h. Volume of cone 1 by 3 pi r square h, which become 1 by 3 into 22 by 7 into r square, means 7 by 7 into height is 14. After simplification, this becomes 718.67 meter cube. So in this way we can carve out a cone from a cube of maximum shape, of maximum height, of maximum radius or diameter. Then we can calculate its volume, we can calculate its height, slant height, curved surface area or total surface area also. I am taking a question here. A sector of circle of radius 15 centimeter. We have a circle. As I can show you, let us suppose this piece of paper is the circle and the radius of this circle is how much? Suppose the radius from center to here is how much? 15 centimeter. Thus, a sector of circle of radius 15 centimeter has an angle of 120 degree. Let us assume which sector I have marked has an angle of 120 degree. A sector of circle of radius 15 centimeter. This radius of the sector is 15 centimeter. I can draw the shape of the circle. I can take the center. I can take one of the sector. I can mention here the radius 15 centimeter. 15 centimeter. Angle is 120 degree. A sector of circle of radius 15 centimeter has the angle 120 degree is rolled up so that the two bounding radii are joined together to form a cone. Find the volume of cone. Now a question comes that how a sector can be converted to a cone. In order to explain you, I have this sector of that circle which I was taking. The radius of this sector is 15 like this, and the sector angle is 120 degree. If I show you that how this sector is possible to convert in a cone, that two bounding radii like this, there are two important things to note. Number one, that this radius of the sector when converted to a cone converts into the slant height of the cone. Second, the area of sector is always equal to curved surface area of the cone. With the help of these two, I can calculate the radius of the cone so formed. I am writing here what are the 2-3 important components when any semicircle or sector gets converted into the cone by joining its two bounding radii. You can see here the radius of circle is 15 centimeter, and you know it that the radius of circle converts in the slant height of the cone. So slant height of cone is equals to 15 centimeter. Agreed. Also the area of this sector is same as the area of curved surface of the cone. So area of sector is equals to CSA of cone. Remember, the radius is 15 is value of the radius of sector, not the radius of cone. So area of sector is central angle theta upon 360 into pi r square. CSA of cone is pi r l. I am writing here capital R to indicate the radius of cone, small r to indicate the radius of sector. Theta is here how much? 120 degree. So this become 120 upon 360 into pi into 15 into 15 is equals to pi into capital R into 15. Please remember, this capital R is the radius of cone and this value is not 15. Whenever you are folding a sector to form a cone, the radius of sector is the slant height of the cone. So this 15 cancelled, this pi get cancelled, 120, 3 ja, 3, 5 ja. So the radius of cone become 5 meter or centimeter as per the unit. I can tell you here slant height is how much? Small l is 5 centimeter. Radius is calculated, small l is 15 centimeter. As you know, the radius of sector is always equal to the slant height of the cone. L square is equals to r square plus h square. That is 15 square is equals to 5 square. You can take here capital R. That is 5 square plus h square. If you simplify this part, that is 225 is equals to 25 plus h square. Answer of h square is 200. So height of the cone become 10 root 2 centimeter. Now height of cone has come out 10 root 2 centimeter. Radius of cone has come out 5 centimeter. And slant height of cone is already known 15 centimeter. What we want to calculate? We want to calculate its volume. So to calculate its volume, what we will do? I will give you calculations here. That is the volume of cone. I can say that volume of cone is 1 by 3 pi r square h, which become 1 by 3 pi means 22 by 7 and r square, radius of the cone is 5, its square, into height it is 10 root 2. So after putting the values, the volume become 1 by 3 into 22 by 7 into 25 into 10 into, in place of root 2 we can write 1.414. This become 1.414 if you want to take it for 3 places. After simplifying, this value of volume become 370 370 is the complete, and then 0.33 centimeter cube. Now one more question where I will tell you how to calculate the volume of a cone which is formed by revolving a right angled triangle about its perpendicular or about its base. A right angled triangle is revolved about its perpendicular. If base is 12 meter, perpendicular is 5 meter, find the volume of cone. Now if I discuss with you by drawing the shape that the base of the right angled triangle is 12 meter and perpendicular is 5 meter. So understood by Pythagoras theorem, hypotenuse will be 13 meter. It is revolved about its perpendicular, so the height of cone is 5 meter, radius of the cone will be 12 meter, slant height of the cone if required will be 13 meter. They are asking to calculate the volume. To calculate the volume after rotation, the shape of the cone will become like this: 12 this side and 12 this side, and height is 5 meter. This is also 13. Volume is 1 by 3 pi r square h. Volume become 1 by 3 pi. You know it is revolved about the perpendicular which is 5 meter high. So 5 meter will be height, 12 meter will be the radius. So 12 into 12 into height is 5. If you simplify, you will get it is 240 pi centimeter cube is the volume of the cone so formed by revolving the right angle triangle of the base 12 and perpendicular 5 about its perpendicular. Now I want to tell you that how a sphere or a hemisphere forms, then what are the results to calculate its volume, and in case of the hollow sphere or hemisphere, what is the surface area, total surface area, curved surface area, etc. As I explained you how a cone forms, cylinder forms, cube forms, cuboid forms, similarly I want to tell you that in order to form a sphere, sphere is a three-dimensional shape, that is it is the shape which need what? It need the space. If you have any circular sheet of metal or any circular plate as I am showing you, and you keep its diameter, a circular sheet has infinite number of diameters. When I have folded, it become what? It become a semicircle. But if I have opened, it become a circle. By keeping its any of the diameter fixed, and when this circular piece of the paper or sheet of paper is revolved, it is rotated about its any of the diameter, then amount of space occupied by revolving in one round of this circular sheet, the object so formed is what? The sphere. This is the formation of the sphere. Whatever the radius of the circle, that is the radius of the sphere in the space. Now if I tell you how a hemisphere forms, if I have a semicircular sheet of paper, this is the semicircular sheet of paper, and if this semicircular sheet of paper is made to convert like a quadrant, and by keeping its one of the radius fixed, if it is rolled or rotated like this, then figure or the amount of space occupied in the space is known as the hemisphere. Similarly, as you know, we can have a hollow sphere, hollow hemisphere. So for these hollow sphere and hemisphere, we have the separate results. Now I would like to explain you that what are the results required to calculate the volume of sphere, the CSA or TSA of sphere, and of hemispheres. One by one I am going here. You can see volume of a sphere is given by the formula 4 by 3 pi r cube, where r indicates for the radius of a sphere. CSA, curved surface area, or lateral surface area, or the total surface area of the sphere is given by 4 pi r square. It is 4 pi r square. A sphere has curved surface area only. So if somebody asks you to make you confused that what is the total surface area, the TSA, CSA and LSA of a sphere are same, that is 4 pi r square. If a spherical object is hollow, its external radius is capital R, its internal radius is small r, then how much volume is required of any material to make the hollow sphere of external radius capital R and internal radius small r is given by volume of hollow sphere is 4 by 3 pi capital R cube minus small r cube. Now volume of hemisphere, as I told you, as the semicircle is the half of circle, similarly the hemisphere is the half of a sphere. Volume of sphere is 4 by 3 pi r cube, so volume of hemisphere is 2 by 3 pi r cube. Volume of hollow hemisphere, as in case of the volume of sphere was hollow, 4 by 3 pi capital R cube minus small r cube. Volume of hollow sphere was 4 by 3 pi capital R cube minus small r cube. So the volume of hollow hemisphere will be given by 2 by 3 pi capital R cube minus small r cube. Now curved surface area of hemisphere, as CSA of sphere is 4 pi r square, so CSA of hemisphere is 3 pi r square. You can observe when a lemon is cut, the entire lemon shape is what? The shape is sphere. When you cut it exactly from center, it gets converted into what? A hemisphere. So total surface area of hemisphere is what? The area of half of the area of the curved surface, that is 2 pi r square, plus when you cut a lemon, one more circle is observed on its cross section. Area of circle is pi r square. That's why when this area of cross section is added to curved surface, then total surface area of hemisphere become 2 pi r square plus 1 pi r square, that is 3 pi r square. Now total surface area of hollow hemisphere, if any hemisphere is in the shape of a bowl of some thickness, then what is the total surface area? Its external curved surface area plus its internal curved surface area plus area of edges, that is ring. So formula is 2 pi capital R square, that is R is the external radius, plus 2 pi small r square, small r is the internal radius, and area of the ring, that is pi capital R square minus small r square. So when these three areas will be added, we will get the total surface area of hemisphere. These are the results, direct results, which will be used to solve the problems of based on hemisphere and sphere, volume, CSA and TSA. Now I am taking an example where some change in the radius is made, then how we compare the surface areas and volumes of a sphere in two cases. The question is, the radius of a spherical balloon is increased from 7 centimeter to 14 centimeter. Initially there was a balloon with the radius 7 centimeter. When air is pumped into it, inflated, and the radius become 14 centimeter. So there are two situations. When air is pumped in a spherical balloon of radius 7 centimeter, radius become 14 centimeter. find the ratios of their surface areas and volumes. How we will find their ratios? So, radius in the first case I am writing R1, that is 7 centimeter, and in second case it is 14 centimeter. Surface area in first case will be 4 pi R1 square and surface area in second case will be 4 pi R2 square. We want to calculate their ratios of surfaces. So 4 pi and 4 pi get cancelled. It left with R1 square upon R2 square. So this becomes 7 into 7 upon 14 into 14 because R1 is 7. So this comes out to be 1 by 4. Hence the ratio of surface areas become 1:4. Second, ratio of their volumes, that is V1 upon V2. V1 is the volume in first situation. This is given by 4 by 3 pi R1 cube upon in second situation 4 by 3 pi R2 cube. This become 4 by 3 pi, 4 by 3 pi get cancelled. R1 cube upon R2 cube, that is 7 into 7 into 7 upon 14 into 14 into 14. This become 1 by 8. So I can say that the ratio of volumes V1 is to V2 has come out 1:8, and ratio of surface areas S1 is to S2 is 1:4 as shown in the first situation. So this is the way to compare the surface areas and volumes under various conditions. Now I am taking an example where the cost of painting of any hollow is hemispherical. Now I am taking an example where the cost of painting of hollow hemispherical shaped bowl or object is required to calculate. The internal and external diameters of a hemispherical vessel are 24 centimeter and 25 centimeter. Diameter outer external is 25 centimeter and diameter internal is 24 centimeter. So with this way I can say radius of outer part is 25 by 2 centimeter, external one, and radius internal is 12 centimeter. Radius is half of the diameter. Find the cost of painting its total surface. As and when we talk about the total surface of any hollow hemispherical object, the formula is, if I tell you this is the total surface area of hollow hemispherical object or vessel. It is given by 2 pi capital R square, that is the external radius, that is external curved surface area, plus 2 pi, that is what? Internal one, we call it small r square, plus pi capital R square minus small r square. This is the area of ring or edges of that thickness. I can show you like this here. This shaded dotted part is the area, this one, and internal is this one, external is this one. To calculate the area, I will say it is 2 pi. 2 pi is common from these two. It is capital R square plus small r square plus pi. R square minus R square by algebraic identity can be written as R plus R into r minus r. This become 2 pi into r square, that is 25 upon 2, 12.5 whole square, plus internal r square, you can say it is 12 whole square. So this become 2 pi into 12.5 square plus 12 square plus pi into r plus r, 12.5 plus 12 into 12.5 minus 12. Now this value is coming out to be 2 pi 12.5 whole square. It is 156.25 plus 12 whole square is 144 plus pi into their sum is 24.5, their difference is 0.5. This become 2 pi into summation of these two values become 300.25 plus pi into this value become, when 0.5 will be multiplied to it, 12.25. So the answer is coming out to be, when this is multiplied, 600.50 pi plus 12.25 pi. If I ask you to add these values, you will say it is 612.75 pi. 612.75 pi centimeter square. This become the total surface area, net area to be painted. If I put the value of pi to be used at 22/7, then answer of TSA in the final form will come 612.75 into 22/7. So first we will multiply it by 22 and then we will divide it by what? 7. So it will be 1925.79, 1925.79 centimeter square. Cost of painting of 1 centimeter square is rupees 0.05, that is 5 paisa. Cost of painting, total surface area will be 1925.79 into 0.05. The product of this value is rupees 96.29. You can say the cost of painting the total surface area of this hemispherical bowl of the given diameters at given rate is rupees 96.29, that is rupees 96 and 29, or you can say 30 paise. Now another question, if surface area of a sphere is 5544 centimeter square, find its volume. Surface area of a sphere is given by 4 pi r square. So you can say 4 pi r square's answer is 5544, or r square become 5544 upon 4 pi. R square become 5544 upon 4 into 22/7. Its calculation is coming 441 and its square root is 21 centimeter. This become the radius of sphere. We want to calculate its volume. We can say the volume of sphere is given by 4/3 pi r cube. You can say 4/3, 22/7, r cube means 21 into 21 into 21. The simplified form of this is 38808 centimeter cube. So with the help of curved surface area or total surface area of a sphere, on comparing we calculated radius. Radius is applied in the formula of volume. So it become 38808 centimeter cube is the volume of this sphere whose surface area is 5544 centimeter square. Now one more problem based upon recasting of hemisphere to converts in some other shape. The diameters of external and internal surfaces of a hemisphere are 10 meter and 8 meter. Hemisphere is melted and recast into a cylinder of diameter 14 meter in a solid cylinder of diameter 14 meter. Find its height means the find height of cylinder. That is, we need to calculate the height of cylinder if it is obtained only from the volume of what? So obtained by melting this hollow hemisphere. The question is, we can say the volume of hollow hemisphere is same as the volume of solid cylinder so obtained. What is required? The height of solid cylinder so obtained is required. I can do one thing. We know that volume of what? Volume of hollow hemisphere. Volume of hollow hemisphere is 2 by 3 pi. The volume of hollow hemisphere is equals to 2 by 3 pi capital R cube minus small r cube. Volume of solid cylinder. Volume of solid cylinder is given by pi. You can say radius is x, then x square, and if height is h, then h. Why I am taking radius x? Because capital R and small r are used for the radius as external and internal of hemisphere. You can say that volume of hollow hemisphere is equals to volume of solid cylinder. That is the value of 2 by 3 pi capital R cube minus small r cube is equal to pi x square h. So this pi and pi get cancelled. Put the value of capital R, that is what? Half of the diameter 5. Internal half of it 4. So this become 2 by 3 into 5 cube minus 4 cube is equals to x square. Diameter of solid cylinder is 14. So this become 7 square into h. So what you can call the value of h? H is equals to 2 by 3 into 5 cube is 125 minus 4 cube is 64 and divided by 7 square, that is what? 49. If you will simplify and solve it, you will get this result will come as 4 by 3 meter. Hence, if a hollow hemispherical shaped object of internal diameter 4, external diameter 10 is melted in a converted into a solid cylinder of dia 14, then the height by comparing these volumes will come out 4 by 3 meters, or you can say it is 1.333 meters, or you can convert by multiplying it 100 into centimeters. Now one more example where the three shapes are to be taken, all three shapes together. A cylinder, I can show you here that there is a cylinder. If there is a cylinder, it has to be its radius and it has some of its say height h. A cylinder, a cone, there is one cone shape you know very well, this. A cylinder, a cone, a hemisphere. You must understand that what is the hemisphere? Hemisphere is the shape like this. This is the suppose hemisphere. A cylinder, a cone, this is cylinder, first thing, second is cone, this is the third one, you can say hemisphere. Have equal radii, that is radius of each of the object is same. So you can say whatever is the radius of cylinder is same as of cone, same as of hemisphere. I can write here radius of cylinder is equals to radius of cone is equals to radius of hemisphere, and that is suppose r units, because all radii are same. A cylinder, a cone, a hemisphere have equal radii and equal height. You have to note here that height of hemisphere is always equal to its radius, because if this is the radius and this is also the radius, so I can say that the height of hemisphere is same as the height of its that is its radius. A cylinder, a cone and a hemisphere have equal radius, so I have written here that is radius of cylinder is equals to radius of cone is equals to radius of hemisphere is taken as r units. And equal heights, that is you can say height of cylinder is equals to height of cone is equals to height of hemisphere. But you know the height of hemisphere is same as the radius, so it is also equal to r. Find the ratio of their volumes. First is the cylinder. Volume of cylinder is pi r square h is to 1 by 3 volume of cone pi r square h is to height of sphere, that is what we are comparing, what height of hemisphere is always equal to radius, so the volume of hemisphere is 2 by 3 pi r cube as the usual result. Here one thing is to be note that this height and this height, these two heights are equal, that is height of cylinder is same as the height of cone and same as the height of hemisphere as mentioned in the question, but height of hemisphere is always equal to its radius, so these two h will also be replaced by small r, because in given that three heights, height of cylinder, height of cone, height of hemisphere are same, and height of hemisphere is always equal to the height of that is its radius. Now this become pi r square into r, because height is replaced by radius of hemisphere, and radius of hemisphere is same as the radius of cone and cylinder as given, is to 1 by 3 pi r square into r is to 2 by 3 pi r cube. We can take LCM 3. So after taking 3 as LCM, what is going to happen? This become pi r square into r become r cube, that is 3 pi r cube. If I have taken the LCM as 3, so here it is 1, so it will be 3 pi r cube is to 3 and 3 get cancelled. This left with pi r square into r is r cube, then 3 and 3 cancelled, this is 2 pi r cube. You can compare, you can see for the ratio it is the simplest form. So you can say here this become 3 pi r cube is to pi r cube is to 2 pi r cube. Pi r cube, pi r cube, pi r cube get cancelled. This left with 3 is to 1 is to 2. So we can say if a cylinder, a cone and a hemisphere having same radii and same height, then we can tell the ratio of their volumes is 3:1:2. Similarly, you can extend to calculate the ratio of curved surface, total surface, etc.